This derivative looks pretty complicated, but because of the properties of natural logs, we can break it down into three much simpler derivatives to work with. Let's do that. So we're going to have the derivative with respect to x. Let's first notice that this is a quotient. So we can write it as the natural log of the numerator, which is x, times x squared plus 1 squared, minus the denominator. And I'm going to rewrite the denominator at this point as 2x to the third minus 1 to the 1/2. So there's our first rule. Now we don't have that quotient involved anymore. For the first one here, we have a product of two things. We can break this up as the natural log of x plus the natural log of x squared plus 1 squared. We still have minus the natural log of 2x to the third minus 1 to the 1/2. And then finally we can pull exponents out front of natural logs when the exponent applies to everything that we're taking the natural log of. That's why we haven't been able to do this yet, but we can do it now. So we're going to have the natural log of x plus 2 times the natural log of x squared plus 1 minus 1/2 times the natural log 2x to the third minus 1. And now we can go through and take derivatives of these things one at a time. So the derivative of the natural log is 1 over x, plus we're going to have 2 times the derivative of x squared plus 1, natural log of x squared plus 1 that is, so we get the derivative of x squared plus 1 divided by x squared plus 1, minus we're going to have 1/2 times the derivative of natural log of 2x to the third minus 1, that's going to give us 6x squared in the top, divided by 2x to the third minus 1 in the bottom. That is the derivative of 2x to the third minus 1 goes in the top, 2x to the third minus 1 itself goes in the bottom. We can clean that up a little bit. We're going to get 1 plus 4x divided by x squared plus 1 minus, we're going to end up with 3x squared divided by 2x to the third minus 1. So it makes taking the derivative pretty easy, but if we needed to go through now and let's say find zeros of this derivative, this was our first derivative, we were trying to find critical numbers, for instance, we would need to put this all over a common denominator and get it written as a single rational expression. So there is some algebra to do to clean this thing up potentially on the back end, but it makes the derivative part a lot easier at the beginning. We didn't have to invoke quotient rules and chain rules and product rules and all of those things all mixed together. That can be considerably more difficult than finding some common denominators and doing some algebra at the very end.